But all right, yeah, but it's good to be back upright and functioning again. Getting ready. It is November now, isn't it? Wow, how did that happen? Uh, we just zipped right on. That is not going to be correct. I'm pretty sure that's wrong. Let me check my calendar real quick here. Yeah, I do not believe it's an A day. I think last day, I think I missed A day, being homesick with A day. That's why I still want to have another one, I guess. But, all right, yeah, it is a B day. B day. So we only have class on Wednesday again this week. If you need help with anything, I don't think we have a we don't have a program this week. I don't have to think about that. We don't have a program this week, so that shouldn't be a big problem. So I think you guys will be able to breeze right through this. So did either of you look at that tutoring thing I put on there for the last program? I'm just wondering. So it is helpful. It is useful. So I may just keep adding that option because it's not very hard to do. I can put it in there and assign it pretty easy. And so I'll just keep adding that option. I'm going to try it. I'm going to go ahead and put it with the programming one. They got their next program coming up, so I think I'll give programming one a chance to use that because I think more of them could probably really use it because some of them are still kind of lost. I don't know if you remember how programming one was, but sometimes it takes a little longer to get into the hang of doing things to start with, and that's where some of them are right now. So but good. I'm glad that you at least looked at it. And I didn't figure you'd use it for the whole time because I think if you wrote your whole assignment with that, it would take so long. You're like, I can just do this faster without it because you know what you're doing more or less. But for someone that's totally lost, it's good to know that it would probably help them learn something and get them a little better off than where they started at. So, all right, let's look at what we have this week. Going to our grade screen. All right, the Module 2 project. We're done with the second unit. I'm not. I didn't do nothing. I was out. But here we go. And that was yesterday's. So we are on Module 3, and we should be able to finish this up before Christmas. So we've got 3 lessons uh, before Thanksgiving, and then we'll have 2 after Thanksgiving, and that'll take us up to the semester finals. So yeah, with Thanksgiving being so late in the month this year, puts back the very short timeline before finals. We got like 3 weeks when we come back, and then we're done for Christmas. So we'll have 2 weeks and then finals week. And I do have the discussion-based assessment where we'll just talk the last week about what we've learned and kind of give you a grade based on your general knowledge of how programming twos worked. And I don't think that's going to be anything real in depth. I haven't even put anything together for that yet. We're a month away from it, but we're going to have all of the lessons done by December 7th, so we'll have the discussion based thing. But let's look at repetition this week. Repetition kind of sounds like loops to me. 3.01. Repet repetitive repetitive. There we go. I was like, wait a minute. I know I'm not saying that right. Repetitive structures. We all have one. You know, that little song that you play on repeat an embarrassing number of times in your head. You know, when you binge listen to that song or any song, there are certain types of code that make it possible. They're called repetitive structures, and programmers use them a lot. Getting loopy. See, I knew there's going to be loops involved with repetition. How do you make sure a repetitive task is completed correctly 100% of the time? Well, it's pretty easy. Just ask a computer to do it. It'll do it the same way every time. You don't even need to say please. Just simply need to use a loop. A loop is a repetitive structure that tells the program to perform a task repeatedly. So to make a loop, you need an action to repeat and a condition that tells the program when to stop repeating. So every time the program completes a loop, it's called an iteration. Repeating a set of instructions or process a specified number of times. Like songs, they do iteration because they have this chorus that they generally repeat throughout the song. Iteration. That's a good word. Loops versus if statements. Okay, there is a difference for sure. Important question. If you want to play your favorite song over and over and over while you're at the gym, first you probably should have some headphones because your neighbor on the next machine is going to get tired of hearing it. He's going to get yell at you. Should you choose an if statement or a loop? Well, even though they may seem similar, they behave very differently. So let's compare if statements to loops. So here is a loop. The program executes the code and jumps back to the start of the loop as long as the condition is true. So example, while you're at the gym, the song will continue to play, only moving to the next part of the program when you leave. So start, if you're at the gym, that's true, it will play your favorite song. You're still at the gym, I will play your favorite song. You're still at the gym, I will play your favorite song. Oh, you've left the gym, end. So it'll continue forever as long as you live at the gym. The if statement executes the code one time. That's the big difference. If you're at the gym, the song will play once and move into the start of the program. Okay, start. Wait, you made it to the gym. Let me go over here, play your favorite song. All right, let's end. If you're not at the gym, it just ends to start with. So that's the big difference. There is some code that's played under a condition in both situations, right? Whatever the condition is for the loop, but the only difference is it will continue to happen until that condition is no longer true. Where if statement says if it's true, I'm just going to do it once. Big difference. For loops. So that's the first type of loop we're going to talk about, and we're familiar with these. Sometimes things are black and white, and you know exactly how many times an action should repeat. Like in a song, you know how many times you're going to repeat the chorus. That's simple. We're going to do the chorus 3 times, and then the song will end or whatever. 3 strikes and you're out, right? 1 chance to finish. 20 minutes until takeoff. You know how many times you can loop. When you need to know the number of iterations before entering a loop, a for loop is the right choice. So check it out. Players can attempt the level exactly 4 times before the game is over. So that's it. After 4 times, you're done. That's a good situation for a for loop. The stage lights flash exactly twice before fading into black. Perfect. Each movie has exactly 3 screenings at the cinema festival. For loops would be perfect for all of those. Controlling your for loops. Stop arguments allow you to control where the repetition begins and ends in a for loop. So we use the range function. Range. Start here, stop here, and then you're done with the loop. It is the part of the for loop where you can specify up to 3 parameters. You can give it a beginning value, say start counting at 1, an ending value, stop at 10, and a step value. I could say count by 2s instead of just going by 1s. So let's look at how these values work. In a for loop, the range can be as specific as you want. Passing one number to the range assigns a variable to the variable a begin value. Select each part of the code to learn more. So define main, for loop with 1 ending parameter. So for I in range. So I is the variable we've chosen to count with. We're counting with I. And the range is 4. So this tells Python to execute the block of code on the following line 4 times. Includes the variable and calls the range function. So count to I 4 times and do this line underneath there. Print Rihanna 4 times plus the string. So let's open up our little idle since they're not putting this in an active idle window. Let's go back here and copy this and see what it looks like. I know they put a little output here, but it's more fun to generate our own. If we paste this in here, there it is, for I in range 4. If we run it, Rihanna 4 times, 0, 1, 2, 3. Of course, remember, Python counts at 0, not at 1. That's where it starts at. And this is where it stops. So when it gets to 4, it doesn't do the loop anymore. But that's fine for us. We just said 4 times. I don't care if it counts 0 to 3 or 1 to 4. We just wanted it to do it 4 times. Now, if we wanted it to actually print 1, 2, 3, 4, we could just simply add 1 to the I value, right? I plus 1. Let's try that. See, now it prints out 1, 2, 3, 4. We know it still counted 0, 1, 2, 3, which is fine. That's how the computer thinks. But we want it to show 1, 2, 3, 4 because that just makes more sense to us, or just makes us feel more comfortable, or whatever. It doesn't matter. Either way, we're just making sure this does this 4 times. So there's the output they show, run 4 times. All right, in parameter. Begin and end parameter. So passing 2 numbers to the range assigns the variable a begin value and an end value. So we could say, here we go, copy. We'll replace this with our new 0 to 14. So this is kind of like counting 1 Mississippi, right? 0 Rihanna, 1 Rihanna, 2 Rihanna, all the way down to 13 Rihannas. So there it is 14 times, because it starts with 0 to 13, goes through this loop. So we told it to start 0, which really, if you think about it, the 0 is unnecessary because it was going to start at 0 anyway. But we can do that. That's where we could tell it to start at 1 and go to 15 if we want to, 1 to 15, which means it would still just go 14 times because it stops. That's the stopping value. It will not loop through the 15th time. So it kind of works that way. So their output 0 to 13. How about when we have the begin, end, and step? So passing 3 values to the range assigns the variable a beginning, ending, and step value. Copy that. Now we said start at 0, stop when you get to 14, and count by 2s. 0, 2, 4, 6, 8, 10, 12. Of course, it stops when it gets to 14. So this goes through 7 times. And the reason we'd want to do that ever is perhaps we're using I in the loop to do something. If we're doing graphics, maybe we want some number to change by 2 every time it repeats, or something. Doing some calculation that we're adding 2 every time. So there could be a reason that we're wanting to use the loop variable and change, instead of going by ones, to go by a different number, just because it could be used. If we're not using it in here, then just do 7 loops, right? If we're not really using the I for anything, it's just extra, makes it more extra complicated to just make it like that for 7 loops. But a lot of times we do use that variable to do something in the loop to make the loop a little bit different. Okay, we're going to increase it by 1 or by 2 or by 3. For loop break statements. Okay, this is new. We didn't learn this back in the Programming 1 class. Break statements do exactly what they sound like. They break out of a loop. So after a break, the program will continue by executing the next statement following the loop. So let's copy this and take a look at it. We'll put it here first. Look at it in this box. Oh, I didn't delete the old program. I just added this to the end. There it is. For loop with break statement. For number in range 10. Okay, so number is our variable this time, and we're doing just 10 loops. And we're saying number equals number plus 1. So we're adding 1 manually to the number in here. If it equals 5, go ahead and stop there. Break. Tells it if this is true, if number equals 5, break right there. Don't finish the loop. Print some number is. Some numbers 1, 2, 3, 4. Oh, stop when you get to 5. So that got us out of the loop early. So the example they give wouldn't really make sense. It's like, I want to do a loop of 10, but when you get to 5, I want you to stop. I mean, we could just do a loop of 4 then. But this gives you a good example of if something happens inside your loop, if something becomes true and you want to abandon the loop early, this is how you do it. If something equals something, go ahead and break out of the loop now. Don't finish. And it doesn't have to be what the loop number is. You know, if this becomes true, because whatever is happening inside your loop may be changing depending on which loop number you're on. So you want to have that ability to jump out of a loop in case something happens. So this is just a good example of how to get out of your loop earlier than you originally scheduled, because we'd scheduled to go through there 10 times. Okay, so the output 1, 2, 3, 4. Did you know? Can't stop, won't stop. Fact, it is possible to write infinite loops, but you should definitely not try it unless you know how to get out of it. Because you get, anytime you play loops, you could end up like in a while loop. If you don't give it a way to get out of the while loop, a while loop can stay stuck forever. And your program, when you hit run, there's nothing you can do. You got to close it because there wasn't a way to get out of it. Infinite loops go on forever. They literally will not stop, which makes your computer freak out until you force quit. Got to force quit, get out of it, or the world end, whichever comes first, and hopefully you'll force quit before the world ends. In fact, many programmers prefer to use for loops because it'll cut down on accidental infinite loops. Because a for loop is not going to be infinite. At some point, it's going to hit that top number in the range, even if it's a huge number. Even if it's you put 1,000,000 out there, eventually it'll get to 1,000,000 and stop. But an infinite loop, just your computer runs. Like define main x equals 2. While x is less than or equal to 2, print are we there yet? Main. Which means if you run this program, it'll just continue to print are we there yet while you're are we there yet forever. Like when you're a little kid and pestering mom and dad on vacation. Are we there yet? Are we there yet? Are we there yet? Are we there yet? Especially with 3 of you, I can imagine your parents heard a lot of what we are we there yet. So but yeah, there's that's an infinite loop. If you run that, you'll have to get out of the program window. Probably you can't shut down the programming window. Well, that would be interesting. Let's just put that in there. So if we said, okay, run program. Oh, it's not doing anything. Why is it not doing anything? X equals 2. While x is less than or equal to print. Are we there yet? Oh, I don't. It's not printing, but it's not doing anything. It became unresponsive. Yeah, I got into a loop. It's like, wait a minute, this doesn't end. I don't know what to do. Exit pages. All right. See, yeah, something went wrong because I put an infinite loop in there. So I let that reload. Oh, something went wrong here as well. Yeah, it really fried everything up because don't do an infinite loop. It uses up all your resources. Your computer just winds up and your CPU gets 100%. Oh, now we got to go back to our page number even. Now that's a good example of why not to get into infinite loops. All right, page 3. While loops. Here's the other loops that we learned. Not all things in life are precise. That's okay. The light in the fridge will stay on while the door is open. The engine will run while the key is in the ignition. Times like these are why the while loop was created. It tells Python to keep repeating an action while this certain condition is true. This type of loop is used when you don't know exactly how many number of times you need your code to run. I needed to keep doing this loop while this is true, but I don't know how many loops that's going to be. Like the game clock runs while the ball is in play. Okay, we don't know how long it's going to be before suddenly the ball's out of bounds and now everything's got to stop. So we won't say run 8 seconds. We'll say just keep running until the ball's out of play. The camera records while the director is called action and while cut has not been called. So once he yells action, camera runs. An activity tracker will count your steps while you're moving. Yeah, I keep trying to get mine to count my steps while I sit here just to give me a little credit, but it will not do that. So using while loops. Although sometimes if I got some music on, if I'm doing a little drumming, my watch will say, "Oh, good, you're staying active." And I'm like, "Oh, hey, a little credit." Although my watch is on the charger this morning. It ain't counting anything. Repetition in a while loop is controlled by whether condition is true or false. You know, Boolean logic. So to create a proper control statement, you will need to use relational operators, right? To compare two values. To tell the while loop, the condition is necessary for it to run. So let's look at how this works. Define main. Now let's just copy this, put it in our programming window. If our programming window is reloaded, it has. Okay. While loop. So x equals 0. So while x is less than 5, print play Laser Kitten album. A Laser Kitten. Wow, that would be interesting. And then print the loop number you're on. And then add 1 to x. So every time you print it, you add 1. And it'll keep going through this while loop until x is not less than 5. So there it is. It goes Laser Kitten album 0, 1, 2, 3, 4. It made it to 5, but when it got to 5, it got outside of our loop. It said, okay, I'm at 5 now. I'm not less than 5 anymore. I'm going to end the loop and continue with the program. So Laser Kitten album. So choose wisely. When should you use a for loop and when should you use a while loop? Great question. Depends on the situation. Use a for loop when you're counting through a range and you're repeating an action for a certain number of conditions. Best for when you know the exact number of times that your code should run. Use a while loop when you're waiting for something to happen, you're not sure, and you're repeating an action while you're waiting on that certain condition. But you don't know the exact number of times you need the code to run. All right, so it's our turn. Try your hand at writing some while loops. Okay, so we get our own little Python got activity. Read the code, try to predict the output. Find main, count equals 0. So while the count is less than 11, which it is right now, print the count. And then add 1 to the count, and that's the end of the loop. So it'll go back and check again. Is it still less than 11? Yes, it is. Print it again. So it should just keep printing it until it gets to 11, and then it'll quit. So let's run. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it stops. Exactly what we expected, because it should start printing the first value of 0 and then keep adding 1 until it got to 11. Let's look here. Read the code and modify the range of the while loop so the count is from 1 to 5. Okay, so we want it to start at 1 this time. So let's change that value to 1. And while it is less than 6, right? Because at 5, it would quit and wouldn't print 5. If we want it to print the count from 1 to 5, we need to let it go ahead and run the loop while it's 5. And don't quit until it gets above that. So now it prints 1, 2, 3, 4, 5. So we told it to start there and print the first number, add 1, and then quit when you get to 6. I don't care about 6. I just wanted 1 to 5. Great job. Okay, 2 to 3. Read the code, try to predict the output. So select run the program and enter the password urock when prompted. So here it is. Define main, password equals unknown. So while the password is not equal to urock, ask what the password is. And print, you guessed correctly. So if you run the program, it says, what's the password? IDK. Nope. It says, nope. What's the password? Is it password? Nope. That's not the password. Well, if I just hit enter, nope. Wait, 0, 1, 2, 3, 4, 5. Nope. You rock. Then it quits. So it's just going to stand there. I can't get past what is the password until I actually type this specific password, capitalizing all the same letters that are capitalized. Exactly. You rock. So that would kind of be an infinite loop until somebody knows what they're typing, but it's not. You guessed correctly. All right, let's look at our, anything down here? Nope. Look at our page 4 here. Looping with lists. So lists are useful for storing information, and loops are useful for repeating information. So together, these two are unstoppable. Loops can be used to print out a list, populate a list with information, and so much more. So here's some ideas. Let's say you're printing a list of Oscar-winning films you have yet to see. You could have a list stored and then a loop to print them one at a time. Boom, 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 boom. Showing episodes of a TV show in the correct order, especially if your list has them numbered, right, in the right order. Populating a character's defense stats in a video game. Adding tracks to the same genre of music playlist. All right, so think like a programmer. You already know how to use loops, but how do you combine them with lists? So we've broken it down. We're going to select each part of this code to learn more, and then we'll check the results here. Hunger Games equal, and that's an empty list. Remember, lists use brackets instead of parentheses, the square parentheses, brackets. And this is the command .append that we use with lists that says add this to the list. The append command goes to the Hunger Games list, which starts out empty, And I'm going to add exactly what's in parentheses as the list. 1, the Hunger Games. And then we're going to add again. 2, Catching Fire. Add again. 3, Mockingjay Part 1. Add again. 4, Mockingjay Part 2. Print the entire list with a loop. 4x in Hunger Games, print x, which means the first time to the loop, it's going to print the first value, and then the second value, then the third value, and then the fourth value. And when there's no more values, it should quit. So let's copy this and put it in our window over here. Okay, empty list, create the list, both 4 appends, and then print. There it is. It went through the loop, and it went through there. We didn't have to tell it how many times, because when it ran out of list items, it left the loop. That's really nice. Not knowing how long the list is not a problem, because maybe we don't know how long the list is. We have a whole long list. Man, I don't want to have to count all those. How many is there? I don't know. I don't care. I can just say, hey, just go through this list and print out every one at a time using the loop number. So this is actually the 0 item in the list, according to the Python, because it's going to start with 0, and it prints all of those out. That's pretty sweet. And it shows, yeah. All right, give looping with lists a try in this Python guided activity. One more Python guided activity. Looping through list, define main, print, I like movies, which obviously I didn't get to go to being sick this weekend. For movies in Pirates of the Caribbean, Frozen, and Harry Potter, print, I have seen plus movies. So for movies in, and we just put the list right here in the line instead of creating the list with the variable ahead, calling, movies equal or something. We just put the list right here in the for command, and then boom, I have seen, and it's going to print them one at a time. Run this. First, it prints this because that's the first print statement. Then it gets into this loop, and it'll go through the loop 0, 1, 2, 3 times. I've seen Pirates of the Caribbean, I've seen Frozen, I've seen Harry Potter. All right, so it uses the loop and puts the loop actually in the for, which that works. Next. Now we're going to put the movies into a list separately called movie queue. Then we're going to print the list down here with the loop. Instead of making it the list right here in the for command, for loop. Hunger Games, Pirates of the Caribbean, Frozen, Harry Potter, and the Philosopher's Stone. In this program, the list is initiated. We create the list first. We add 4 things into the list, and then print the list with the loop. All right, let's look at another example. Populated an empty list. Tickets equals nothing. Change the loop to run 5 times. It says, set up the run 5. It says, for I in range 0 to 0. Well, we did say, okay, 0 to 5. Prompt user for a number. So we're going to do an input statement of an integer. Please enter a number, press OK. And so we're going to add that to our list of tickets. So I guess this would be like, okay, how many tickets do you need? I need 4. Now it loops through there again, because we got 5 people in line, right? I want 2. Give me 8 tickets. Give me 3 tickets, and I'll take 4 tickets. So it looped through 5 times with 5 input statements, added all those numbers to our list, and then printed the list right here, 4, 2, 8, 3, and 4. Oh, it wants us to use these numbers, though. It gave me some specific numbers. This is not exactly the output we're looking for. Well, that's because I didn't use your numbers. Let me use your numbers, see if it makes it happy. 1, 4, 6, 7, 9. Okay, now it's happy just because I have to use the numbers they want. Review the feedback, select next with money. But that's an interesting way to use the for loop. For repeated to populate a list, like I could say, what's one of your favorite movies? What's one of your top favorite TV shows? What are your top favorite video games? YouTube influencers, whatever, and you can sit there and ask So you ask it 5 times and then say, here they are. Here's the ones you listed. So we could use a loop to populate a list. Read the code, try to predict the output. Looping through list in Python. Define main. Number equals integer input. Enter the total number of theaters. And then we have an empty list called ticket. So we've got a variable called number that's going to be an input statement. We have an empty variable list called ticket. Use a loop to input the number of theaters into the list. So here's a loop for I in range 0 to whatever number we said on the input statement was the total number of theaters. So 0 to that number, calculate the total sum of elements in the list. Cost equals another input statement. Enter the ticket price for each theater. Example, $5.50. So we're comparing all the theaters in the area, or at least we're checking all the theaters. This theater's $5.50, which I want to find out where that one is. And then we're going to add to our list ticket, which we have this empty list ticket. We're going to add whatever the cost is. So we'll create a list of ticket prices at all the all elements in the list and divides by the total number of theaters. All right. So we said enter the total number of theaters. So that gave us that number. We're going to enter the total ticket price for each theater. And then at the end, we're going to take the average by adding up the tickets and dividing it by the total number. The sum of ticket. So we can just say sum of ticket and it'll add up all the numbers in our list. Round, and they're telling us to round it to 2 digits. That's the round command. So we got a lot of commands in here that helps us. The round command and the append and inputs. Let's run this. All right. Enter the total number of theaters. Let's say we have 4 theaters. And the ticket price for each theater, it's not going to be $5.50. Let's say it's like $11 and $12.50. And this one over here is going to be the cheap one at $10. And then there's a $14 because they do everything with 3D or something. So the average cost is $11.88. That sounds about right. I said 10, 11, 12.50, and 14. That sounds like about $11.88 average. So in this program, we ask the user to input the number of theaters, store the variable in. So that's what you get if you like, what's the average price to see in a movie? Well, look at the 4 theaters around me. This is the prices of those 4 theaters. So, a little under $12, $11.88. So this got some good stuff right here, using lists and loops combined, input statements inside to populate lists, doing some calculations all together. There's a lot of good things happening. Just a few lines of code here. Just a few lines of code. All right, let's move this on. Complete the reading practice using Python. Complete the quiz. Let's look at our assignment. Specify the statement that provides the most control over iteration in a loop structure. Which one allows you the most control? Select the instance where you'd like to use a while loop instead of a for loop. What's the third argument in a range statement? For variable in range 0 to 8. What is that third number? Select the true statement about the functional differences between the for index in range 4 and the for index in range 0, 4. What's the difference? Suppose you have the following program. What will happen if the if condition is executed? For num in range 0 to 15, if num equals 14, break. So there you go. Simple 5 questions this week. Nothing bad. Good stuff there. So that's it. That's all we got this week, guys. I'm sure next week, and we'll probably be doing loops in our program. What you think the odds are of that, huh? All right. Well, you guys have a great week. If you got anything going on, any questions, let me know. We'll have class Wednesday if you got anything going on that you need help with. Otherwise, we'll see you next week or in algebra class, whichever comes first. I think I know which comes first. All right. Have a good one, guys.